Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In this video, we will take one more example based on medians and quartiles of continuous random variables. So let's begin. This question is from May-June 2008, paper 7, question number 7. Let's read out the question. If Usha is stung by a bee, she always develops an allergic reaction. The time taken in minutes for Usha to develop the reaction can be modeled using the probability density function given by f of t is equal to k upon t plus 1 when t is varying from 0 to 4 and f of t is equal to 0 otherwise, where k is some constant, and they are saying show that k is equal to 1 upon ln of 5. Let's try to show this. But here they haven't used any variable for this continuous random variable time taken in minutes. Okay, so let's try to use some particular letter for the same. Can we say let t be the time in minutes, taken for Usha to develop the reaction, Okay, this will help us. This variable will help us. Okay, in the second part. Now, because we are supposed to find out k, I know that the probability density function of this t, okay, the area under the curve of this probability density function of this t, it will be equal to 1. So that means if I integrate f of t with respect to t for all real values of x, what should I get? I should get the answer as 1, correct? So this means, but f of t is defined as non-zero value from 0 to 4 only. So instead of from minus infinity to infinity, I'll take 0 to 4. So from 0 to 4, what is f of t defined as? It is k upon t plus 1. Okay, and I have to integrate k upon t plus 1 with respect to dt. Okay, and this integration will be equal to 1. So this k I can take outside. So I have to integrate 1 upon t plus 1 with respect to dt when t is varying from 0 to 4. Now you might have studied in pure maths 3 that integration of 1 upon x with respect to x, okay, is equal to ln of mod of x plus c. Similarly, integration of 1 upon x plus a with respect to x, where a is some constant, this integration is equal to ln of mod of x plus a plus some constant c, correct? So here this integration will give me what? This will be equal to k into integration of 1 upon t plus 1 will be ln of mod of t plus 1, okay, and the limits will be from 0 to 4. And this total value to the left is equal to 1, correct? So what do we get from here? We get this as k into ln of t plus 1. So if I put 4 here, so 4 plus 1 will give me 5, minus, I'll put the lower limit here, so 0 plus 1. So ln of 1 it will become, this is equal to 1. So from this what do I get? I get this is k into ln of 5. Why? Because ln of 1 is 0. This is equal to 1. So that means from this, what do I get? I get k as equal to 1 upon ln 5. Correct? So we have shown the first part. Now what is the second part they are saying? Find the probability that it takes more than 3 minutes for Usha to develop the reaction. Okay, we had already defined capital T as that particular variable, the T being the time in minutes taken for Usha to develop the reaction. So that means they are asking that T has to be greater than 3. So what is probability of T greater than 3? Okay, they are asking this particular thing. So T greater than 3, so that means I will have to integrate from 3 till the upper limit here. What is the upper limit of T? That is 4, for which f of T is defined. So I will have to integrate f of T from 3 to 4, correct? But f of T is k upon T plus 1, but k we got it as 1 by ln 5. So can I say this is equal to integration of, in place of k I can write it as 1 upon ln 5 into 1 upon T plus 1. Okay, and I have to integrate this whole thing with respect to T when T is varying from 3 to 4, correct? So what do I get this as integration? This 1 upon ln 5 being constant I can take outside. So it becomes 1 upon ln 5 outside, and I have to integrate 1 upon T plus 1 with respect to T. So this will become 1 by ln 5 outside, and integration of 1 upon T plus 1 again will give me what? It will give me ln of mod of T plus 1, correct? And I will have to put the limit 3 to 4. So what do I get here? I get this as 1 upon ln 5 outside, and inside the bracket I'll get this as ln of 4. If I put the upper limit, 4 plus 1 is 5, so I'll get ln 5 minus 3 if I put the lower limit, so 3 plus 1 is 4, so I'll get this as ln 4. So can I say this is 1 by ln 5 into, this is ln A minus ln B, and you might have studied this is equal to ln of A by B, correct? So that is ln of 5 by 4, correct? So therefore probability of T greater than 3 will be equal to this particular value. So if we solve this particular value on the calculator, what do we get this as? This is equal to 0.1386 something something, which in terms of 3SF I can write it as 0.139, correct? So that means probability that it takes more than 3 minutes for Usha to develop a reaction is 0.139. What is the third part of the question? They are saying find the median time for Usha to develop a reaction. Now what is median? It is that value of T to the left of which the area under the curve is 0.5, correct? Or median is that value of T which divides the area under the curve of f of T into 2 equal parts, correct? So let's say let M be the median. So if M is the median, then we know that probability of T being less than or equal to M, this is equal to what? 0.5. Yes or no? So this means if I integrate my f of T, what is my f of T? 1 upon ln 5 into 1 by T plus 1. If I integrate this, okay, from what to what? From 0 to M. This value should be equal to how much? This will be equal to 0.5. So again, 1 by ln 5 I can take outside. Integration of 1 upon T plus 1 with respect to T will give me what? It will give me ln of mod of T plus 1, correct? 0 to M, and this is equal to 0.5. So from this what do I get? I can say if I put this M here, so what do I get? I get this as ln of mod of M plus 1 minus if I put 0 here, so ln of 1 it will become, and ln of 1 is 0. So this is equal to this ln 5, I can take it on the other side, so this becomes 0.5 into ln 5, correct? So this means if this ln, I take it on the other side, if I take the anti-log, okay, here, so m plus 1 will be equal to what? It will be equal to e raised to 0.5 into ln 5, correct? So from this, what do I get? I get this as m plus 1 is equal to, I will have to solve this particular thing. So this becomes something as 2.23606 something something. So from this, what do I get? M as, from this I get m as 1.23606 something something. So in terms of three significant figures, can I say this is 1.24 minutes? Because m is what? M is that value of t, and t is here is measured in minutes, correct? Hope you have understood this one. So this answers the part 3 of the question also. That's it for this video. Thanks a lot for staying together this long with this video. If the video was useful and you enjoyed watching it, then please like and share the video. Subscribe to the channel and press the notification bell so that you don't miss any updates from this channel. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.